pure rolling. All surface are rough and the friction is sufficient for pure rolling. We have to find out the time period of oscillation of this system. So no slipping, assume no slipping occurs at all surfaces. Assume no slipping occurs at all surfaces. Find the time period of oscillations of the system. Yeah, no. We have done only rolling body, no? Now a plank and a rolling body is brought into the picture. So this will be the, what are that? Let it be cylinder. Two cylinders are there on which a plank is kept. M2 mass of cylinders. Solid cylinder, let me take it. M1 mass of plank. Okay, carry on, no? So will you go for torque method or energy method? I think here is what a student has to take a decision. What method you pick up, no? So that will make the problem very simple. The torque method or the torque force method will be very, very, very difficult because you have to take care so many equations here. Let's go for energy method because we know work done by rolling friction, net work done by rolling friction will be zero. We have a better idea. Net work done by rolling friction should be zero. So then who will displace action agent? So what I do is like, I'll just take a plank, I'll push it towards right. Then I'll reach. So then what when this spring will be compressed, this will be elongated, the net force will be towards right, and they'll start rolling. So this surface also rough. Now friction, I assume no slipping occurs at all surface or friction is sufficient for pure rolling. So what is the oscillation energy? We'll calculate first. What is the oscillation energy? So the oscillation energy will be, in what all form the system can possess. Let me have one more diagram. We have to show all the velocities, all the velocities which are possible for that Planck system. No, let it be velocity of the Planck v1. Why they will have velocity like this? If you displace towards right, the spring force will act in this direction. Kx1 you write it, or yeah, x1 let it be, and this spring force will act here. I displace the plank towards right, so this will be compressed, this will be elongated. So 2kx1 is acting. 2kx1 force when it acts, it wants to move towards left. So here the friction by them will be in this direction. Then the friction here will be in this direction. Okay, now we know if a friction acts at highest point, F3, this F3. So therefore this will have velocity V2 omega 2. Okay, these are all some. In the rolling motion, we had some basic picture. So in what all form, in what all form, I think it should be F1 only. Yeah? Don't change because try to notice this one. What is this F1? Because these two will oppose the motion of Planck. So this F1 and F1. Action reaction equivalent opposite on the cylinders. It should be F1 should be towards left. Fine. Now, if you're on a rigid body, if your force acts at highest point or above the threshold point, the friction at the lowest point at the ground work point should be in the direction of applied force. This F1 will become like external force for that one. So rolling friction at the ground will be towards left. Okay, carry on now. Now, what is the oscillation energy? The oscillation energy will be kinetic energy of the plank m1 v1 square by 2. Then next, translational kinetic energy of the cylinders. Since there are two cylinders are there, then rotational kinetic energy 2 times of IO, O will write it, IO omega 2 square by 2 plus 2 springs are there, 2 into K x1 square. Okay, any relation between this one, V2 should be equal to R omega 2 at the lowest point. Let me indicate few points. This is P2. This point is P1. No. V2 equal to R omega 2 where? At P2. For no slipping or further, A2 equal to R omega 2. This is where? At P2. No. Similarly, for no slipping at P1, V1 should be equal to V2 plus R omega 2 or A1 equal to A2 plus R omega 2. This is at P1. Okay, this what is the velocity of the plank V1? Then what is the velocity of highest point of the solid cylinder? V2 plus R omega 2. Okay, this is a background for no slipping. Okay, let's get into, let's differentiate this. So dE naught by dt, this should be m1 by 2, 2v1 dv1 by dt. 2 already gets eliminated. So this should be 2v2 dv2 by dt I naught 2 omega 2 d omega 2 by dt plus k 2x1 dx1 by dt. What is dx1 by dt? v1 should be equal to dx1 by dt. Am I right? The displacement of plank should be equal to the compression or elongation of the spring. How much plank moves by, say, 1 centimeter? How much the spring will elongate by 1 centimeter? This will compress by 1 centimeter. So therefore, that V1 should be equal to dx1 by dt. Let's and okay, this one m1 v1 a1 plus 2 m2 v2 a2 plus 2 I naught omega 2 alpha 2 plus 2 k x1 v1. So we should replace what, like omega 2 we should replace, and also v2 we should replace. So I'll go for one more step. m1 v1 a1 2 I naught omega 2 I can write it as v2 by r. Okay, what all we have next again? Okay, so sorry, yeah, one more. No. Okay, again, still I think so many things we have to replace. No, so v1 will be there. X will be there. V2 and alpha 2 should be replaced here. V2 what I can write it as I think first only we should have done replacement. No? Okay, okay, no problem. I think first only we should have done here. V2 we would have written V1 minus R omega 2. Then omega 2 will be V2 by R, and again further V2 will be V1 minus R omega 2. We'll do one thing. I'll replace in the beginning only, so that will be well. First do replacement, so it'll be easy for us to differentiate. M1 V1 square by 2 M2. V2 will be V1 minus R omega 2 whole square plus I naught omega 2 V2 by R whole square kx1 square. So this will be further V1 what we can write it as. So omega 2 what we can write it as V2 by R. We have to omega 2. Okay, omega 2 I brought V2R V2 by R, and further V2 I'll write it as V1 minus R omega. Okay, this, yeah, no, okay. R alpha 2, R alpha 2, I can write it as A1 minus A2. We need one constant equation. One more constant equation is needed. I'll simplify. I got it. Okay, now this will be A2 equal to, okay, fine. Okay, I think somewhere this is what we are missing. Huh? So I'll substitute this R alpha 2 as A2. Then we'll get this relationship. Okay, now it will be very easy to replace here. So similarly, V1 equal to V2. Okay, I think we can now make it very easy. So R omega 2 is V2 and V1 is equal to V2. Already V2 I should replace, no? V2 will be V1 by 2 whole square. Plus 2 will be there, I naught. Omega 2 I can write it as V2 by R. Try to see this. Okay, look at this one. This I replace. What is omega 2? Omega 2 will become V2 by R. What is V2? V1 by 2. So it will become V1 by 2R. Okay, we have all the equations in hand. Okay, let's now write everything in order. V1 square by 2, V1 square by 4, I naught V1 square by 4R square, Kx1 square. This will be much easier. Huh? So this will become 1 by 2. So 3, we can't add up. No, let it be as it is. Now I'll differentiate. M1 by 2, 2V1, A1, M2 by 4, 2V1, dV1 by dt, I naught by 4R square, 2V1, d1 by dt, plus K, 2x1, dx1 by dt. This is equal to 0. So M1 V1 A1 plus M2 by 2 A1 I naught I naught V1 by 2R A1 plus 2K X1 V1. I think V1 will get eliminated. So 0 equal to M1 plus M2 by 2 plus I naught by 2R. This is A1 equal to minus 2K X1. R square. I think I missed it. It should be R square. I note. I think I note value. I can 2 by 5 mr square. No, m2 r square. Okay, I can replace one more step. Oh, lengthy calculation. This one. No. Okay, we'll take care about this one. What is I naught? I naught is cylinder. No, it is m2 r square by 2. Solid cylinder they are. So m naught r square by 2. So this will become m naught by 4. Or say m2 by 4. So we'll get one more step. 3m2 by 4. This will be much easier, no? So a1 equal to minus 2k m1 plus 3m2 by 4. 2 pi 4m1 3m2 by 8k. Intentionally, I wrote m1 m2. We can assume m2m like that. Okay, you get connecting bodies. What is this? Motion of connecting bodies, Planck. So what we did earlier, there was only Planck, it was only Planck, or it was only cylinder. Now Planck and cylinder. Like that, you may get motion of connecting SHM of connecting rigid bodies. So in books you see that one. They'll connect one spring here, one spring here. So go for energy method. You can do by torque method will be very, very lengthy. So initially what happened from slipping conditions, you should try to simplify like this. Lightly write energy equation. Show that either the Planck or cylinder is executing SHM. Now you have to ask questions, sir. Who is executing SHM? Cylinder or the Planck? The system. The total. I think I can't show the diagram more than this. The cylinders, how the motion of cylinder will be rolling and also translative motion will be like this. Sir. Both the cylinders you try to imagine will be like this. What about Planck? Planck will be like this. So what is the motion of the Planck? Will be only translative. What about the cylinder? Will have both rotative, translative motion. Both will be identical cylinders. And there won't be slipping occurs. So like this will be the time period of oscillation. Okay, it'll be very challenging for you, especially this chapter, no? So many different ideas all happen will be available. So what student have to do is like you should focus more on the diagram aspect. So understand the situation given. Once you have a clarity of the diagram, no, little bit okay. Okay, we have another 5 minutes. We'll take the next one more.